Example 2. Find the exact value of the 6 trigonometric functions of the angle theta in the given triangle. All right, so here we've got a brand new right triangle. Okay, so it's going to be the same kind of problem as example 1. Okay, so we're going to start off looking at our triangle, realizing again that we have a right triangle and we have our designated angle theta. And again, we are given 2 sides of the triangle, and we know we need to go and get the third side first, so that once we have all 3 sides, then we can form our 6 trig ratios. Okay. All right, so let's look at this. Which sides do we have and which one are we missing? All right, so let's start with the hypotenuse. So if we go straight across from the hypotenuse, okay, if we go straight across from the right angle, we know that the hypotenuse is the square root of 5. So this is the C value. This is the hypotenuse. And I'm trying to get in the habit of coloring that yellow for you. Okay, so let's figure out what we're missing. Okay, so here's the angle theta that we're going to be making our ratios based off of. If we go straight across, we are missing the opposite side. Okay, so that's what we need to go and calculate. Remember, you can call that either A or B. I'll just go ahead and call it A. Okay, we have the remaining side, which is the side next to theta. So here is your adjacent side, okay, which has length 2. Okay, so we have the adjacent side. All right, since we have a right triangle, we can go ahead and use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for the opposite side. Okay, so let's go ahead and plug in everything we know. Again, we know I've labeled A as the opposite side, and we know the hypotenuse is referred to as C. So the adjacent side, that's going to be our B. Okay, so let's go ahead and plug everything in. So A, we've labeled that as the opposite side. We're missing that, so we're going to leave it as A squared, plus B is the adjacent side, as you know, as far as how we have it labeled. Okay, so that's going to be plus 2 squared. That's going to equal the hypotenuse squared. That is the square root of 5. C is the square root of 5. You need to square that value. Okay, so let's go ahead and simplify. So we're going to get A squared plus 4 is equal to the square root of 5 squared. Okay, if you have the square root of 5 times itself, okay, remember what happens. If you take a square root and you multiply it by itself, the square roots go away and you're just going to get what's underneath. Okay, so this is going to give you 5 on the right. Okay, we have A squared plus 4 on the left. Okay, we're solving for A, so we need to get the A squared by itself. So we're going to subtract 4 from both sides. Okay, so we're going to get A squared is equal to 1. Okay, and then to undo the square, you need to take the square root of both sides. Okay, and go with the positive version. So you're going to get that the A value is 1. Okay, all right, so that means the opposite side has a length of 1. Okay, now that we have all 3 sides, we can go ahead and form our trig ratios. All right, so let's start with sine. We know that sine is the opposite over the hypotenuse. Okay, so let's put that together. The opposite side has length 1, and the hypotenuse has length the square root of 5. Okay, we need to go ahead and rationalize the denominator here. 1 over the square root of 5 is the sine, but it is customary to state the answer where you don't have a square root in the denominator. So let's go ahead and rationalize. We're going to multiply the top and the bottom by the square root of 5. All right, and then multiply across the top and across the bottom. 1 times the square root of 5 is square root of 5, and then the square root of 5 times the square root of 5 is 5. Okay, so here is the sine value for theta. All right, moving right along, if we want to do the cosine is going to be the adjacent over the hypotenuse. Okay, so read off the picture. The adjacent goes in the numerator. The length of the adjacent side is 2. The length of the hypotenuse is the square root of 5. So there's your cosine. Okay, but we do need to rationalize. So let's take this value and multiply by the square root of 5 over the square root of 5. And then multiply across the top and the bottom. So we're going to get 2 square root of 5 over 5. Okay, that's the cosine of theta. All right, moving on to tangent, which we know is sine over cosine, okay, which works fine. You could actually take this sine value and divide by the cosine value. But these are kind of complicated numbers. So the best thing to do here, since you already have your sides of your triangle labeled, just remember that tangent is the opposite over the adjacent. Okay, so let's put our our opposite side in the numerator. That's going to be 1. And then the adjacent side will go in the denominator, and that's 2. Okay, so this is a nice answer. The tangent of theta is 1/2 or 0.5. Okay. All right, so now let's go to the cosecant. Okay, the cosecant is 1 over the sine. Okay, so 1 over sine theta. So you can just go back to your sine work and flip the fraction, okay, because 1 over anything flips the quantity, flips the fraction. Again, remember what we did when we did example 1, what we learned, okay? If you flip the final answer here, okay, for the sine, if you flip the square root of 5 over 5, it's going to send the square root of 5 back to the denominator, and you'd have to rationalize again. So your best bet was going back to setup, initial setup before you rationalize the denominator, and flipping that fraction. Okay, so this would be the square root of 5 over 1, which simplifies to be just the square root of 5. Okay, that's one way to do it. You could have also remembered that since, you know, cosecant is the 1 over the sine, and sine is opposite over hypotenuse, cosecant is the same thing as hypotenuse over opposite. Okay, so you could have gone to your picture and written down the hypotenuse, which is the square root of 5, over the opposite, which is 1, so you would have come up with the same quantity, which is the square root of 5. Either way you do it, you should get the same answer. Okay, moving on to secant of theta. We know secant of theta is 1 over the cosine of theta, so all you have to do is flip the cosine. Okay, you get into the same kind of situation. Here's your final answer for cosine. If you flip the final answer, it's going to send a square root back to the denominator, and you're going to have to rationalize. So save yourself some work and go back to the initial setup before you rationalize the denominator. Okay, the cosine is equivalent to 2 over the square root of 5. Flip that fraction. Okay, so you'll get the square root of 5 over 2. You could have also looked at secant, since it's 1 over cosine, and cosine is adjacent over hypotenuse. We know the secant is the same thing as the hypotenuse over the adjacent. Okay, so you could have gone to your right triangle and in the numerator put the hypotenuse, which is the square root of 5, over the length of the adjacent side, which is 2. So you would have also come up with the answer of the square root of 5 over 2. All right, last thing is the cotangent of theta. We know that's 1 over the tangent of theta. So all you have to do is go to the tangent and flip the answer. The answer for tangent's really nice. It doesn't have any square roots. So just flip the fraction to 2 over 1, which is 2. So that's going to be your cotangent. Okay. You could have also applied, you know, the alternate definition of cotangent. We know cotangent's 1 over tangent. Tangent is opposite over adjacent. So just flip that definition. Cotangent is adjacent over opposite. Okay, so going off your triangle, the length of the adjacent side is 2 and the length of the opposite side is 1. You also come up with the answer of 2. Okay, so either method works. All right, let's try one more.